Hey guys, I kept losing at Tekken, and I decided that instead of improving, I should externalize my problems and make a leverless controller. I'll be honest, I already made one from plastic, and I'm obsessed with it. It's one of my favorite things I've ever printed. It doesn't make me better at Tekken, and it works exactly the same as a keyboard, but it just feels magical to use. It feels a lot more wondrous and a lot more like playing than a normal keyboard. I want to capture that feeling again, but sturdier and prettier and way more satisfying. Essentially, just a version in wood. I decided to use wood that I already had in stock. And luckily, for something this small, I had a lot to pick from. I decided with walnut and purple heart. Oftentimes, purple heart can be really loud and garish, but for something like this, I thought it would work really well. After choosing the wood, the first thing to do is jointing. Jointing is prepping the wood for glue up, but more generally, it's making the wood square and ready for subsequent operations. I'm supporting the wood on the planer sled with some thin shims underneath, secured with hot glue. This is because if you run it through the planer thicknesser without the support underneath, it can come out still warped and bowed due to the pressure from the planer thicknesser pushing it flat. I only end up showing me jointing the wood once, but I end up doing it a few more times. I do it once with the purple heart, and I actually make a mistake later on, and I do it again with another block of walnut. So I have two flat and parallel faces. The next step in jointing this board is to make the edges of the board flat and square, meaning 90 degrees to the first surfaces that I prepared. And for some reason, I don't feel comfortable using the formal terminology here. I'll try it out and you can tell me. The next step in jointing this board is edging the wood. Yes, see, that doesn't sound quite right. So the tapering jig is used so we can reference the flat side that we've prepared on the piece of wood to get a 90-degree angle along the edge. It also references the flat side along the tapering jig so that we can run it along the fence and get a straight line through the table saw. I used a few shallow cuts to remove all the raw wood. Then, just like face jointing, using the planer sled, I can get rid of the jig and reference the newly cut edge on the fence. I got a little self-conscious while writing this script and decided to double check all the terminology about jointing. So there is face jointing, which I did on the planer, and edge jointing, which I did on the table saw with the tapering jig. Technically, jointing doesn't include the ends of the board, just the four sides I've done so far. If you include the final step of squaring up the ends, which I'm doing here, that's apparently called milling. The problem with being self-taught is my teacher is an idiot. Also, edging is not the correct term for edge jointing either. Edging means something else entirely. I think it's related to veneering, but if I were you, I wouldn't Google it. Now it's time to get the board to the correct dimensions. I mark it out and transfer the dimensions around using the square. Also, I have to point this out before anyone else does in the comments. I used auto white balance while recording all of this footage. So if it randomly looks extremely yellow tinted, I just want you to know I didn't go to Mexico, nor did I AI generate it using that gross ass Ghibli piss filter everyone else has been using. I use a featherboard to keep the workpiece tight against the fence. I'm sure you're aware, but a featherboard is also a safety feature that prevents kickback, preventing the table saw from launching the wood straight back at you. I resaw the board in half using the bandsaw. This will become the base and the top of the controller. I don't have much experience using a bandsaw and I'm still learning how to use it effectively. I made a few mistakes in just this simple cut. I think I pinched the bandsaw blade during outfeed using the red push block, and when it finally came off, I almost pushed my hand through it. It doesn't look that dramatic when it actually happens on camera, but I was so glad I was using a push stick. Then we're back at the planer thicknesser again to take off the band saw marks. During this step, I'd also like to get it to dimension for the CNC machine. One full rotation of the height adjuster takes off 1.6 millimeters of material, and with that knowledge, you actually have a lot of fine control over the height of the cut. The machine does have a built-in ruler, but I wouldn't trust it at all and I wouldn't recommend it. So I was aiming for 20-35 millimeters. So using this strategy, I got within 0.02 millimeters of my target. And for Americans in chat, that's less than a thou. So it's time to get it into the CNC machine and hollow out the inside. This is when it's going to finally start looking like the final product. I'm using the classic trick of painter's tape on both the wood piece and the spoil board with super glue to secure it in place. The grid of holes was made by the CNC machine, so I can use this right angle bit of plywood here as a jig to square up the workpiece to the machine's coordinate system. So I have to probe the workpiece so that the machine knows where it is on its workbed. And I nearly have a heart attack here because I try to probe the other side. The cables catch on the probe and almost pull it off. And I have to do this really sketchy hold on the probe and keep it in place. It's supposed to be this way, not horizontal. I'm gonna have to do it again, do it again. Everything that I just did, do it again. All right, awesome. Rotated 90 degrees. Should it be making that sound? That's pretty loud. That's very loud. Maybe my bit is blunt. All right, well, I'll see you in an hour when this is done. As you can see, it went pretty well. The buttonholes are all here. And it got all the way through the piece of wood, which is what I wanted. And it didn't cut into my spoil board too much. As you can see, it literally just started cutting into the tape in some places, and there's no tape here, but it didn't even get through all the way to the tape. It's just one small problem. When I was probing, clearly I made a mistake. It's a little bit too far to the left because this wall is really thin. You can see here, the curve here is properly done, but over here it's a sharp point, and this wall's very thin. This wall's very thin. So, do I do it all again? Or, my dad gave me a suggestion. What if I just cut these sides thinner too, and instead of letting this be a really thin piece, can you see how much that's budging? It's so thin. Oh. Then, what we do is put a frame around it. Now, I don't want to throw this piece out straight away, so I'm going to try that method where I put a frame around it. I might regret it. It's probably easier to just start from scratch, but we'll see how that goes. I'll have to change my design a little bit. All right. Okay, it was just way easier to just completely redo this part. I will try to save the other one in another video, so remember to like and subscribe if you want to see that. But I got lazy. So this is what it's supposed to look like. Curve all the way around. Curve, curve, curve. So this is the one that I'll be going with for this video, and I'll try to fix the other one in another one. All right. Yeah, I ran away from my problems and decided to focus on the purple heart buttons for a while. I got sad with the base mistake I made and didn't really want to think about how to make the frame to support the thin walls. I actually redid the base completely 2 weeks later, but it happened back to back in the edit just for clarity. I prepped the purple heart for the CNC machine using the same steps as the walnut, including the jointing, the taping, and the super glue. I decided not to include too many shots of the CNC working here because, well, one, it's boring, and two, I don't really have the lighting to make it work because the CNC blocks almost all of the shots. And it's also in the corner of my shop tucked away without any good lights. Trypophobia warning. This is... Oh, the lighting. This is actually, if you can guess, the buttons. So just CNC'd that. I did a run. I did a run of this where the glue wasn't strong enough, so it started wobbling. And I had to stop it and do it again. And this time I ran it a little bit too slowly because I was worried that the glue wasn't going to stick because I thought the piece was too tall. Oops, you didn't hear that. So what I did was ran it a little bit slowly, but if you pay attention, if you can see right there, it just burns in a few locations. I'm gonna have to sand that down. So straight out of the CNC and the bandsaw, this has bandsaw marks on the top and router burns on the side because I'm a dog shit CNC programmer. And as you can see, it took me 10 minutes of sanding to go from this to this. And there's 13 buttons, so I have about another 2 hours of sanding ahead of me. I had a great idea on how to get a consistent chamfer angle on all of the buttons as I sanded them. Just use an angled block as I sand. This worked pretty well as a temporary solution. I did come up with a better one later on that will more reliably make good buttons. This temporary solution also had one fatal flaw. See if you can guess what it is before it happens. A splinter just shoved into my nail. I'm dying. I'm dying. Can you see that? Oh my, let me see if I can get this on camera. It's in my nail. Oh. You see? Right there. It's like splintered into my nail. I am never woodworking again. This is it. I was sanding. All right, let's try to get this out. After removing the splinter, I finished off the rest of the buttons using the same technique, this time being a little more cautious about running my fingers along the jig, if you can even call an angled piece of wood a jig. Then I moved on to mounting the keycaps. I'm using a 3D printed mount for the Cherry MX red switches and 3D printed inserts for the keycaps, so all the intricate mechanical parts will be plastic. I did some research after finishing the project and discovered a lot more possible options than just using Cherry MXs, and I think I'd like to explore them for my next controller. So on test fitting, the 3D printed mount for the switches was a little tight, so I had to chisel out around it to get it to fit. I'm actually shocked. I didn't expect it to sound this different than the plastic version. That's crazy. I don't think most people are interested in the electronic steps of this project, so I'll be glazing over it mostly because the video is long enough as it is. Briefly, the border that I'm using is a Leonardo, which has its compatibility limitations compared to, say, a Raspberry Pi Pico, which I believe is standard. What I've done so far is I've flashed the software onto the board, so the computer should think it's a Leverless controller when I plug it in. I wanted to test that the software actually worked, so I thought, what's a better way to do that than to play a ranked match of Tekken? Okay, when I touch these together, I should kick. It's his promotion match! Okay, you're welcome. This is a free win for you. Oh my god, he's just gonna spam it. No, 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 no. I need to go back. I need, block. Block. No! Punch. Punch him. Punch him. Punch him. Do it again. No! No, he perfected me! No, who could have predicted this? Put it in the hin. Put. Just, I got him. He didn't perfect me. Okay, well, I think it works. I think it works. If he offers a rematch, this guy... No! No! Have a look at this. This is really satisfying. Oh, ah! Very satisfying. I'm gonna put it right next to the camera so you can hear. Yeah. So the next thing to do is solder in all the switches. I'm starting by daisy chaining the grounds across all the switches. I recently bought this automatic wire stripper, and if you do any kind of electronic work ever, I highly recommend this tool. I think I might be uniquely stupid or something, because every other method of stripping wires, a plier wire stripper, an X-Acto knife, scissors, or teeth, I just always mess it up. I cut through the cable or strip too much wire or just something. This tool is literally the only thing I can use, and it probably saved me like 2 hours of time during the soldering and like 2 inches of my hairline. I decided to remove the pin sockets and the barrel jack because I thought it wouldn't fit in the controller otherwise. This ended up adding a lot of extra work because I didn't really have a good system to do this. Because I just broke off the sockets, there were these forks that were still soldered into each pin. I heated the solder to remove them eventually, but what made it really difficult was the large thermal mass of the pliers cooled off the whole thing instantly, and it re-solidified the solder every time I tried to grab it. I tried using rosin thinking it would help, but it didn't really make a difference.
How'd you get in here, Maya? Maya? What you doing? Maya, come here, touch. Good girl, sit. You like soldering? You love soldering. Who let the door open for you? You're gonna burn yourself. You're gonna catch on fire because the solder's gonna make you catch on fire. Out of here, out of here. Fish. Fish.
So I soldered the ground daisy chain to the ground and all the switches to the requisite pins. I'm very happy with the look of this. The yellow Leonardo matches the wires, despite the fact that no one will ever look at this once the controller is actually made. The thing that isn't so pretty is the solders underneath. Just pretend we didn't see this. Oh, okay. So after 4 hours of soldering, I have to check whether this works, and I'm really worried that A, I overheated the board and broke a component like a resistor or something like the microcontroller, and B, I'm wondering if pulling out the plug, what is it called, the power plug? This might not be the best. This might not be the best strategy. Whoops. I hope this doesn't break it. I'm worried that I short-circuited one of these circuits. So, well, let's try it out. Is it plugged in? Oh my god, it's not plugged in. Nothing happened when I pushed this down. Had a heart attack. Okay, let's plug it in first, okay, King? Alright. Her not spontaneously moving when I plugged it in is a good sign, because that means nothing's short-circuited yet. Oh my god, okay. Back. Forward. Down. Ah! It's working. Okay. We're in business, boys! Oh my god. Everything's working. Everything's working. Okay, holy crap. Let's go. All we have to do is glue it up now. Put a hole in the side for the micro USB to come out. And then put a finish on it. Okay. I was so glad to be in the home stretch. The next few steps also really clean it up, and it actually looks good for the first time in the project. I use a flush trim bit to remove the excess that I left intentionally from the CNC machine. Then I chamfer all of the buttons and the outside of the frame. It felt like my design was coming to life. Basically, I was really happy with the way that it was going, so be prepared for some gratuitous glamour shots, even though the project isn't even close to being done. Okay, so I tested this guy, and he's looking very stable now that he's dried. So the next step is to get some epoxy onto the buttons and get that guy into there, and the Arduino locked into that guy, and then after that dries, I'll put the base in. That's the idea. So you may be wondering, are you mixing epoxy on X-ray film? And the answer to that question is yes. And now your next question might be, why do you have X-ray film in your workshop? And the answer to that is to mix epoxy. Just kidding. My granddad didn't need them anymore because he's dead. Okay, let's try to click this in. I haven't tried it. I've been scared to try click it in because if it clicks in and it works, it's going to be stuck. So, point of no return. Oh, it works. Okay, one of them snapped. Two of them snapped. Okay, as long as it doesn't fall out when I flip it, that's fine. Because I just don't want it to touch the wood glue that's going to be on this surface here. Oh, I forgot to mention. It's going to be important. It's going to be important that when I put in the... Can it focus, please? Can it? It's going to be important that when I put in the keycaps, I have to make sure that it aligns with the grain direction, because I would prefer that this is going horizontally, and when it gets put into the keyboard, it's going to be doing the same thing to the hitbox, that is. That's the idea, anyway. Back to YouTube. They're okay, but they could be better. So what I'm thinking is, now that I have a perfect little center point, I don't have a lathe, but I do have a drill. So what I'm thinking is maybe... Wait, that actually worked. And then I can rub it along sandpaper. Oh, that actually is crazy. That actually is crazy that worked. Hold on. That's insanely circular. This is so much better than what I was doing. I ran all of them through and they're looking very round. And the chamfers are much more consistent. I'm sure that if I had started with this strategy, it would have been much better, but I'm very happy with this. Next step was to rat out the bottom with the flush trim bit. What I didn't know at the time was this was going to be the single most dangerous thing that has ever happened to me while woodworking. And the scary part is, while looking back at this footage, I noticed it was loose much earlier than I actually realized in the moment. I just keep going. I didn't see it. How did I not see it jump up a little? Holy fuck. That is horrifying. Ah! Okay, when you tighten it properly, it doesn't slip out. Who would have known? If only these things came with instructions. SMH my head, for real. But the routering went down without much of a hitch. Well, just one hitch. A chip out. I was going in from the end grain as carefully as I could, but alas. It's okay. You can fix it with some glue and some tape, and it will be seamless in the final product. It turned out really well. The flush trim bit worked. It's feeling really sturdy now. And while that dries, so all of this is flush now, except for where the cable is here. That's gonna need a bit of work, otherwise, A-okay. What I'm paranoid about doing is just whoosh, cutting the cable in half. Maybe it's wise to start this away from the cable. Yeah, that looks like it's gonna work. It's flush. Okay, let's try the other way. Probably gonna block the camera, so you'll have to forgive me. Okay, that looks perfect. Just need a bit of sanding. I think it's a little too small. I might have to make it a little taller. I think a little taller would look better. I'll do that again. Do it again. That's crazy. Thanks for watching all the way to the end of the video. If you'd like to show your support, you can always like and subscribe. To finish up, here's a short sound test, so you can really hear how it sounds. And just compare that against the plastic one. All right, thanks for watching. Bye.